My husband gave me a new bracelet, and I looked on the inside, and it said angle on it. And I said, why'd you put angle on my bracelet? And he said, it's so you'd have your own inscribed angle. Get it? Anyway, so we are studying inscribed angles. What the heck are those? Well, an inscribed angle is an angle that has a vertex on the circle, on the edge of the circle. And the sides are chords. So you can see that it goes from one point of the circle to the other and one edge of the circle to the other. It doesn't have to be like the diameter can be shorter or longer. Well, not longer than the diameter. So in this case, angle CBD is an inscribed angle. So there's a cool relationship between inscribed angles and their intercepted arcs. So in this case, angle B is the inscribed angle. The arc it intercepts is arc CD. So first of all, we're going to look at that relationship by, I did a simple inscribed angle where one of the chords is a diameter and the other one is some random chord. This is just to make the proof a little easier, but we'll explore it for other types of inscribed angles too, where the chord is not a diameter. So first of all, I'm going to classify this triangle. Well, I know these two are radii, so that means they are congruent. Well, if I have two congruent sides on a triangle, it's automatically isosceles, which means that this angle here, BCA, is also congruent to angle B. Now I'm going to find the measure of, I'm going to tell you that the measure of angle ABC is just x. And I'm going to find the measure of angle CAD, which is the central angle here. Well, if the measure of this angle is x, that means that angle's x too. Then I'm going to use the exterior angle theorem. You may remember that this here, that exterior angle, is equal to the sum of the remote interior angles, the ones that are far away from it. So that means I can say measure of angle A equals x plus x. That means CAD right here is 2x. Well, okay, and then that means then if I'm looking for the arc CD, that is also 2x. Well, what does that tell us about the relationship? Notice I didn't have actual numbers here. I just made a general case. If I picked 30 for the angle here, that would be 60. If I picked 40, this would be 80. So there's a relationship where the inscribed angle is always half of the intercepted arc. But we'll go ahead and explore these with these two links. So we're going to look at inscribed angles and see if that holds for any type of triangle, even when the chord is not a diameter. And also we'll look at different angles that intercept. Now here's an interactive demonstration that you can find on GeoGebra. And this is the link on your notes. You'll notice, first of all, that this is the central angle here. It's rounding a little bit, so let me make it a nice even number. So here's the central angle. It's 104 degrees. The arc here will be 104 degrees, and that should actually show. Actually, I'm going to stay on that version. And here's the inscribed angle, and it's half of the 104 degrees. This is true whether the angle, see, even if the inscribed angle is not going through the center, it still has that relationship with the intercepted arc. So you can see 16 degrees, 8 degrees. I can make a really obtuse angle, 212, 106. And as it goes, even as I move the point along, it stays the same. It's just related to how long this arc is. So it doesn't matter where the angle is on the circle. It is always half of this arc. This is another demonstration here. So I have the arc that I can move just like before. And you can see I actually have 3 inscribed angles. So you can see that as I move the points around, like before, the angles are stay the same because they're connected to this arc here. And there's still half of that measure. So the interesting thing is you can have 3 different angles here, but they're all going to have the same measure because they intercept the same arc, no matter how big that arc is. So the conclusion we got after playing with those angles is that, 1, An inscribed angle is always half the measure of the intercepted arc, whether it was the chord was a diameter or not. And also, when we looked at the different angles that we could inscribe from the same arc, we found that if they come from the same arc, the inscribed angles will always be congruent. So let's go ahead and do an example. We're going to find the measure of, this is actually an inscribed triangle, so we have 3 angles to look at. We do know that arc DB is 68, and we're going to find each of the angle measures. Well, we know that's an inscribed angle, and it's half of that measured arc. So the measure of angle DCB is 68 divided by 2, or 34 degrees. Now, this next part, angle D up here, that goes with this arc down here, CB, and it's almost like a major arc. I probably could have put, well, it's going to be the same either way because this is a diameter. How many degrees is that? That's 180 degrees up here, and the arc is 180 degrees. So to find the measure of angle D, I will have to go ahead and just divide 180 by 2, which means it's 90 degrees. That's an interesting thing because that means anytime I have the diameter, isn't that arc always going to be 180 degrees? So anytime you have a triangle where one of the sides is the diameter, that angle that's not on the diameter will be 90 degrees, so your triangle will be a right triangle. We've been working with those a lot in this circles unit. So there's your right triangle. Then I'm just going to use the fact this is a right triangle to figure out what this last angle is, and it is 56 degrees, which means this arc must be 112 degrees. So the interesting conclusion we found is if an inscribed angle subtends, that's a fancy math word, subtends right here, that means here's the inscribed angle, it's subtending this arc. I like the word intercepting, but I'm good with subtends as well. So if it subtends a semicircle, all right, then it is automatically a right angle. So some things to think about in this section of notes. What is an inscribed angle? Can you describe it to me? What is the relationship between an inscribed angle and the arc it intercepts? What kind of triangle is inscribed in a circle when one of the sides of the triangle is a diameter?